Come unwrap some holiday magic this season in Denver, where the lights are brighter and the shopping is grander. The shows are more spectacular, the trees taller, the festivities merrier. So come for your holiday traditions or make some new ones with your friends and family in the Mile High City, where the season feels a whole lot more wonderful. Discover great hotels and more things to do at milehighholidays.com.
Discover unbeatable deals and convenience at your neighborhood family fare supermarkets. Score exclusive deals, earn rewards, join clubs, and clip digital coupons for extra savings all in one place. Our exclusive offers bring savings straight to your card. Explore a wide range of local products that support your community. With easy pickup and delivery options, saving time and grocery shopping has never been easier. Family Fare is all about making your grocery experience easy and affordable and your one-stop shop for all your grocery needs. Family Fare in your neighborhood.
This is SpaceTime, Series 23, Episode 104, full broadcast on the 5th of October 2020. Coming up on SpaceTime, looking for an answer for that ultimate question, are we alone in the universe? Discovery of a second alignment plane in our solar system. And a school bus-sized asteroid swoops past the Earth. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Well, forget what you've seen on Star Trek. It looks like our part of the Alpha Quadrant, at least, is quite devoid of any form of advanced alien life. In fact, a new study has found no signs of alien technology in 10 million nearby star systems. The findings, reported in the publications of the Astronomical Society of Australia, suggest we really are quite alone, at least in our little part of the universe. Astronomers base their conclusions on the deepest and broadest search ever conducted for signs of alien technology. The authors used the CSIRO's Murchison Wide Field Array Radio Telescope in outback Western Australia to scan low frequencies across a patch of sky around the constellation Vela, a region known to include at least 10 million stars. This was the most complete scan for advanced extraterrestrial life ever conducted. But it appears if there are advanced civilizations out there in this part of the galaxy, they're really good at following the Prime Directive. One of the study's authors, Professor Stephen Tingay from the Curtin University node of the International Centre for Radio Astronomy Research, says the telescope was searching for technosignatures, powerful radio emissions, at frequencies similar to FM radio bands. These could indicate the presence of intelligent life. The Murchison Wide Field Array has an extraordinarily wide field of view, thereby allowing astronomers to observe millions of stars simultaneously. The authors observed the sky around the constellation Vela for 17 hours, looking more than 100 times broader and deeper than ever before. But the dataset found no technosignatures, no signs of intelligent life. The thing is, the human civilization has been broadcasting radio signals for 100 years now. That means with a receiver powerful enough, someone 100 light years away should be picking up our signal. Although exactly what they'll make of reruns of I Love Lucy and the Honeymooners is anyone's guess. Of course, the authors say that since they can't assume how any possible civilizations out there might utilize technology, they need to search in different ways, and radio telescopes are really only just one method. Tingay says the results weren't surprising. After all, as Douglas Adams noted in Hitchhiker's Guide to the Galaxy, space is big. Really big.
Well, we were using the MWA to look for the radio signals produced by molecules in space. So, for example, nitric oxide. That was the primary scientific aim. But what we realised is that we can reuse the same data to look for technosignatures, so possible signals associated with advanced civilizations. We found nothing in that respect. But what we did achieve was basically 100 times better than has ever been achieved before in a search for such signals.
When you say techno, what do you mean? Are we talking about old episodes of I Love Lucy? Because that's sort of what people think about. Or are you talking about the sort of molecules that are likely to be found in the atmosphere of a planet in a developed civilization?
Broadly speaking, a technosignature could be considered any electromagnetic byproduct of the activities of a technologically advanced civilization. So obvious things are things like mobile phone communications using radio waves. If they leak off away from a planet, then that could be detected and would be a marker of a technology. Old episodes of I Love Lucy, that's the classic example.
Yeah.
But yes, also the detection of products in the atmosphere, for example, that are the byproducts of technically advanced activities. So anything in that respect would be considered a technosignature. So it's quite a broad category of things.
And what sort of area did you look over? Well, how much of the sky were you able to search?
We were looking towards the constellation of Vela, which is along the Milky Way. So there's a lot of stars in that direction. The great characteristic of the MWA is that it has an enormously wide field of view. So we were able to produce the survey over 400 square degrees of the sky, which is really an enormous area to look at in any given instant.
As Douglas Adams says, space is really big.
Classic quote. I use it a lot.
Let's go back to the original purpose for the study. You were looking for specific molecules.
Yeah. So a lot of people know that radiation is produced by atoms. The transition between different energy levels within an atom can produce electromagnetic radiation. But the same thing is true for molecules. So all manner of molecules can change their electronic structure slightly, and whenever they do that, they can produce electromagnetic waves. For example, we were searching for nitric oxide, and it has a number of predicted energy transitions that would result in radio waves being produced at specific frequencies within the frequency range that the MWA is sensitive to. So we were performing one of the first searches for those types of molecules.
Why nitric oxide?
Well, it's something that should be relatively abundant, but has its transitions in this lower part of the frequency band. So I don't believe it's been detected in this frequency band before. So it's a matter of looking at molecules that should be there, doing the quantum mechanical prediction of what the transitions for that molecule should be, and predicting the frequencies at which the emission should appear, and then going searching for it. So that would give a really interesting new probe into molecular gas in the galaxy if we could detect and trace such molecules and measure their velocity distribution and their spatial distribution as well.
Is it a surrogate for other molecules that are harder to find, other atoms that are harder to distinguish?
It can be. It's also a fairly fundamental building block when it comes to building much more complicated molecules, things that are much more important to organic life, sort of at the complexity of sort of proteins.
Right, so amino acids, things like that.
Amino acids, exactly. So it's a very interesting molecule in that respect, and therefore could also be taken as a bit of a tracer for areas in which those sorts of more complex molecules could arise. During
this search, you took the opportunity to have a look to see if there were any techno-signatures out there. Were you upset when you didn't find any? Or was it sort of, we didn't really expect to find any, but, blue sky research is always good.
Yeah, so the search for extraterrestrial civilizations is clearly of great interest and of fundamental importance, also extraordinarily difficult. And it's one of these areas where you have to make a lot of assumptions with respect to the sorts of signals that you might predict. And one thing that I really hate is making a lot of assumptions. So there's an interesting way to look at radio telescopes and the search for extraterrestrial intelligence. It's interesting to think about it as a parameter space. So with a radio telescope, we can search through an 8-dimensional parameter space. So, for example, area of sky, sensitivity, polarization, and other characteristics that our instrument is sensitive to. So that's a massive 8-dimensional space. It's become referred to as a haystack, as in searching for a needle in the haystack. So you can work your way through that parameter space in a very unbiased manner, which is what we've done. And we've been able to explore a factor of 100 more of that parameter space than anyone has previously. The only problem is that even then, that represents one part in 10 million billion of the total parameter space. So there is a very, very long way to go if you want to search through all the possibilities in an unbiased manner. So not disappointed because it was not expected that we'd find anything. But what's important to us is the process of improving our techniques, going deeper and deeper and deeper into that parameter space. And that will set us up for when the square kilometre array comes along, which is sort of like 100 times more sensitive than the MWA. So we'll really be able to carve up that parameter space.
That's Professor Stephen Tingay from the Curtin University node of the International Centre for Radio Astronomy Research. And this is Space Time. I'm Stuart Gary. Still to come, discovery of a second alignment plane for our solar system, and a school bus-sized asteroid sweeps past the Earth. All that and more still to come on Space Time.
See care in a new light at Madonna Rehabilitation Hospitals, where top medical minds lift you up, where the very best in specialized rehabilitation brings out your very best, where over 60 years of breakthroughs in research and technology spark your newfound strength. In our world-class hospitals, this is something greater than rehabilitation. It's renewed strength for life. Learn more at madonnarehab.org.
Okay, let's take a break from our show for a word from our sponsor, Namecheap.com. As their slogan says, search and buy domains from Namecheap at the lowest prices. Now, this is the service that our team at Bytes.com use to buy and manage our domain names, and we're really happy with the service support and value we're getting. Buying the right domain name shouldn't be hard, and with Namecheap, we've found it to be anything but that. And you can find your dream domain and join over 2 million happy customers when you register with Namecheap. Trusted with well over 10 million domains, you'll know you're in safe hands when it comes to turning your website idea into reality. And they've got some excellent tools to help you find the right name, like the handy search engine. All you do is type in your desired name, cross your fingers, and press search. And if what you want's already gone, and it does happen sometimes, they'll come up with some great alternative ideas. And if you're looking for some new inspiration, try the new website domain name finder, Beast Mode. It'll help you discover thousands of domain names fast. We've found their prices to be excellent, management tools intuitive, and they're easy to use with excellent custom support if you need it. All in all, it's a great experience all round if you're looking to pick up a domain name or two. So why not check them out and help support our show at the same time? Just visit spacetimewithstuartgary.com/Namecheap. That's spacetimewithstuartgary.com/Namecheap, and Namecheap is one word. You'll find the URL details in the show notes and on our website. Just visit the support page. That's spacetimewithstuartgary.com/Namecheap. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
Astronomers have found a second alignment plane in our solar system. The discovery is based on a new study of the orbits of comets. The findings, reported in the Astronomical Journal, have important implications for models of how comets originally formed in the solar system. Planets and most other bodies in our solar system circle the Sun either on or very close to an orbital plane called the ecliptic, which is 7.25 degrees off the Sun's equator. But there are exceptions, such as comets. Comets, especially long-period ones, can take tens of thousands of years to complete each orbit. And they're not confined to the area near the ecliptic, instead coming and going in various directions. Scientists looking at the paths of these long-period comets have found that their aphelia, that is, the point in their orbits when they're furthest away from the Sun, tends to fall close to either the ecliptic plane or a newly discovered so-called empty ecliptic. Models of solar system formation suggest that even long-period comets originally formed near the ecliptic and were then later scattered into their current orbits through various gravitational interactions, most notably with the gas giant planets. But even with planetary scattering, a comet's aphelia should remain somewhere near the ecliptic, so that means other external forces are needed to explain the observed distribution. The new study, by Assistant Professor Arika Higuchi from the University of Occupational and Environmental Health in Japan, says the solar system does not exist in isolation. She points out that the gravitational field of the entire Milky Way galaxy, in which our solar system resides, would also be exerting a small but not negligible influence. So Higuchi and colleagues studied the effects of this galactic gravity on long-period comets using sophisticated computer modelling equations governing orbital motion. She was able to show that when galactic gravity is taken into account, the aphelia of long-period comets tends to collect around two specific planes. The first is the well-known ecliptic, but there's also a second empty ecliptic, inclined with respect to the disk of the Milky Way by about 60 degrees. Higuchi confirmed her predictions by cross-checking her findings with NASA's Jet Propulsion Laboratory's Small Body Database, which showed that the distribution does have two peaks, one near the ecliptic and the other near the empty ecliptic, just as she predicted. This is a strong indication that the formation models are correct and that long-period comets originally formed on the ecliptic. However, because the sharp peaks don't exactly line up with either the ecliptic or empty ecliptic planes, but rather near them, it means more work is still needed. There's a part of the picture we're yet to understand. This is SpaceTime. Still to come, a school bus-sized asteroid sweeps past the Earth, and later in the science report, a new study warns that Greenland's ice sheet is likely to lose more ice this century than at any other time in the past 12,000 years. All that and more still to come on SpaceTime. An asteroid the size of a bus has zoomed past the Earth, flying just 21,000 kilometres above the planet's surface. That's closer than many Earth-orbiting satellites. The good news is that unlike the last asteroid close encounter with Earth, asteroid 2020 SW was detected weeks ago by the NASA-funded Catalina Sky Survey in Arizona, well before its encounter with our planet. Follow-up observations were then able to confirm its orbital trajectory to a high precision, ruling out any possibility of an impact. Scientists were able to determine that the 10-metre-wide asteroid would make its closest approach over the southeastern Pacific Ocean before continuing on its journey around the Sun and not returning to Earth's neighbourhood until at least 2041. You may recall that back in August, asteroid 2020 QG swooped down around 3,000 kilometres above the Indian Ocean, hours before it was discovered by the Zwicky Transient Facility Observatory. And that officially made it the closest non-impacting asteroid ever observed. This is SpaceTime.
The holidays start here at Baker's with a variety of options to celebrate traditions old and new. Whether you're making a traditional roasted turkey or spicy turkey tacos, your go-to shrimp cocktail, or your first Cajun risotto, Baker's has all the freshest ingredients to embrace your traditions. Baker's, fresh for everyone.
We've locked in low prices to help you save big store-wide. Look for the locked in low prices tags and enjoy extra savings throughout the store. Baker's, fresh for everyone.
And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study warns that Greenland's ice sheet is likely to lose more mass this century than at any other time in the past 12,000 years. The findings, reported in the journal Nature, are based on simulations showing projected mass losses ranging from 8,800 billion tonnes to 35,900 billion tonnes based on best-case, worst-case scenarios. Researchers say the findings again show the need to decrease carbon emissions in order to stop the likelihood of the Greenland ice sheet contributing to sea level rise. A new study has identified 41 areas of genetic code linked to being left-handed. The findings, reported in the journal Nature, also found 7 areas of genetic code associated with being ambidextrous. More troubling, the authors say they also found correlations between left-handedness and specific neuropsychiatric problems including schizophrenia and bipolar disorder. They say the links could explain the overrepresentation of left-handers in some neurodevelopmental disorders. A new study has confirmed that kids really are less likely to get COVID-19. The findings, reported in the Journal of the American Medical Association, are based on international research looking at data from 32 studies, which involved some 41,640 kids and 268,945 adults. It confirms that kids and teens, people aged under 20 in other words, are far less likely to contract COVID-19 than adults, and that was especially true for kids under 14. But even the under-20s were 44% less likely to suffer from secondary COVID-19 infections compared to older people. More than 1 million people have now died, and over 34 million have been infected by the COVID-19 coronavirus since it first spread from its origins in Wuhan, China. Well, if like me you're a night owl, there's a bit of bad news coming. It seems that old saying, early to bed and early to rise, makes a person healthy, wealthy and wise, may at least be partly true. A report in the British Medical Journal has found that people who go to bed early are more likely to be in better health and physically more active compared to night owls. The study assessed the bedtime preferences, or sleep chronotypes, of people with type 2 diabetes, finding a connection between bedtimes and healthy active lifestyles. It found that night owls or evening chronotypes, that is, people who go to bed late and consequently get up late in the morning, have excessively sedentary lifestyles, characterised by low levels and intensities of physical activity, and that is putting their health at greater risk. In fact, researchers found night owls tend to exercise 56% less frequently than their early bird counterparts. The study examined 635 patients with type 2 diabetes, each wearing an accelerometer for 7 days to record the intensity and time of different physical behaviours, including sleep, rest and overall physical activity. The study found that 25% of participants were morning chronotypes, with a preference to go to bed early and wake up early, with the average bedtime being before 11 p.m. 23% of people turned out to be evening chronotypes. Yay team! That means average bedtime's well after midnight. And I bet the early morning types don't party hard. YOLO! Forget those offers for quick riches from Nigerian princes. A self-styled Nigerian preacher has decided the best way for her to make money is to sue those questioning her ministry. So much for turning the other cheek. Tim Mendham from Australian Skeptic says the preacher, who's been accused of promoting the idea that even babies can be possessed by demons, is suing one of her critics for the paltry sum of $52 million.
Nigeria has a long history of fervent religious following. Christianity, full of the hand-waving, sort of speaking in tongues and sort of going into trances, etc., sort of Christianity. It's also got a strong Islamic sector as well. But the Christianity parts of it, probably not all of it, but there are certainly very virulent preachers of some forms of Christianity, at least, who are promoting demons, who are suggesting that young people, women, babies are possessed. There's a firm belief in this. There's a certain freneticness that happens at their meetings, etc. And there are numerous cases of women, children and babies being murdered because they are supposedly possessed by demons. Leo Igwe, who's a Nigerian, he's a known humanist skeptic. He's visited Australia a number of times, and we've had presentations by Leo. He's been an ongoing campaigner against these witch claims and the churches behind them, and he has suffered accordingly. To being assaulted, bashed up, thrown in jail at one stage, all range of things. So he is someone who takes his skepticism and humanism to very great lengths to his own personal cost and danger. He's now living overseas, actually, fairly understandably. But this particular preacher, who's one of the more charismatic of the fraternity, is now suing Leo for something he didn't write, very weird, for an article or a book which she is claiming said she was a phony, etc. He is not mentioned in the article. He says he didn't write the article, but she's suing him for $50-odd million anyway. She is well known for doing this, for putting in what you call vexatious against whoever.
Basically.
Yeah, that's not. Yeah, to a certain extent, it's certainly to try to stop them from saying things, which is what a slap suit does, but to scare them off. But they're so outrageous. The amount they're claiming is such ridiculous, tens of millions, of hundreds of millions of dollars or pounds of Nigerian currency to try and stop people, just becomes a joke. Now, the trouble is she has the followers who will then take a more extreme approach to people who criticise her. So that's the danger. Leo's been nominated by us, actually, for a number of awards for his activities and his bravery, actually facing physical threats and physical danger and harm. So he's a well-known international campaigner for humanism against these extremes of religion, and he's paying the price. But I doubt if this will actually get to court.
Leo's not the only one. These sorts of legal proceedings to shut people up are quite common, aren't they?
Very much so, actually, and certainly in the skeptical world, there's a former naturopath named Britt Hermes, who's American, who went through all the courses, and she was quite a celebrated naturopath, quite a key figure for promoting naturopathy, which of course had a lot of problems with it. And she was being a student in Germany, and she was sued because of statements she had made about one particular naturopath in America and their supposedly charity money-raising activities. And this naturopath then took Britt to court in Germany for slander. And, of course, Britt was a student at the time in Germany. And also, actually, when she got hit with a lawsuit, she was actually 4 weeks pregnant. So she wasn't in a great state to be sort of fighting a legal suit at the same time. The Australian Skeptics set up a fund which had contributions from around the world to defend Britt in a law case. And, of course, in Germany, where she was living, you often don't get costs applied in a law case. You just got to wear the price for your own lawyers, etc. Eventually, it was the judgment was found against the naturopath in favour of Britt Hermes, but she still had to pay costs, and we covered those, which basically tried to protect skeptics from these slap suits. All the money raised, it wasn't all spent on Britt. There is a sizable amount still, and that's being put into a defence of science fund. None of it going to skeptics, etc., but defence of people who have been hit by slap suits or whatever just for being sceptical.
Slap suits are a big issue in Australia. I know they still are in some American states, but not others.
The worst place for slap suits used to be the UK, where the payments being issued by the court were huge, and you'd often find people, one person makes a statement in one country and the second person gets upset in another country and they take it to court in the UK because that was where they're going to make the most money. I think there's been a bit of a clampdown on that, but in Australia, yeah, we've had slap suits. It's the sort of thing that happens all the time when someone threatens to sue you just to shut you up. We will take these things seriously. We do not want people who are silenced because they're saying the right thing against people who are, how can I say, in some instances, obviously dodgy, other instances, perhaps they're sort of misguided. But it should be an open debate. It should be sort of people have to prove their case, the case of a product. They have to prove that it works. And if the authorities are not coming forward and doing their job of regulating such people, then it comes down to individuals calling them out.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.